Okay, so let's see. The block is sliding to the right at this speed. It's brought to a halt. I think we got three things here, right? We got that, we got that, we got this. Okay, so we can do the SUVOT first for this. So let's do that. This is a SUVOT then if equals MA problem, right? So let's SUVOT, S-U-V. Our initial velocity is 9. Our final velocity is 0. The displacement is positive 18. And before we even do all this, right, let's decide that if it's sliding to the right, and it stops sliding to the right, the acceleration is negative. This is going to be a negative number. Even if I mess up my signs, I'm going to make it negative, okay? But I'm going to be careful here. This is positive, that's 0. We use no t to solve for a. So v squared is u squared plus 2as. 0 squared is 9 squared plus 2 times a times 18. Okay, so let's see, negative, it's going to be parentheses, 0 squared minus 9 squared, right parenthesis, divided by 2, divided by 18, negative 2.25. Okay, so now we need to solve a force problem, right? If it's sliding to the right, if it's sliding, that's not relevant, right? If it's sliding to the right, this dynamic friction, which we figured out in part A, that is just 0.31 times 6 times 9.81. We figured that out. I explained that in part A. That guy will be to the left, so let's draw that. 18.2466. That guy will be negative, and then there's some unknown force. We just don't know. Which way is it? Is it also acting to the left, or is it acting to the right? Just don't know. Those are our forces, right? So it looks like this, negative 18.2466 plus F is equal to 6 times negative 2.25. So really double check your, do some, use actual kinematic formulas to solve for your acceleration. Use your acceleration intact with its positive or negative sign. If you don't do that, you're just not going to get these right. Okay, so let's see. I'm going to do, what this ends up being is this times this, and I'm going to add this to this side. So times 6 plus 18.2466, 4. Right, so that's about positive 4.75 newtons. Which is interesting, right? This force ends up being definitely to the right. It's definitely acting to the right. And that's because this thing would tend to decelerate more rapidly than that. Okay, without, if you recall, it decelerates at like 3.05 or something like that, right? So without that force acting to the right, it would decelerate more rapidly, but because of that force, it's decelerating only at 2.25. So don't look at these and just say, well, I know which way that force is. You might or you might not.